Good evening. Good evening to all of you. Myself, Basuraju KS. I'm physics faculty at Saremvi PU College, Davangere. So, ಇವತ್ತಿನ ಕ್ಲಾಸಲ್ಲಿ we are discussing regarding current electricity. Current electricity is a interesting chapter because you are already aware of concepts of current electricity from class 10 standard. So, same concepts: current, resistance, resistive, heating effect, electrical instruments. So, ಇದನ್ನ ಇಲ್ಲೂ ಕೂಡ ನಾವು ಎಕ್ಸ್ಟೆನ್ಷನ್ ಸ್ಟಡಿ ಮಾಡೋದ್ರಿಂದ ಇಟ್ಸ್ ಅ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಚಾಪ್ಟರ್. At the same time, it's an easy chapter and important chapter for exam point of view. ನಿಮಗೆ ಗೊತ್ತಿದೆ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಕೂಡ ಇದರ ಇಂಪಾರ್ಟೆನ್ಸ್ ವೇಟೇಜ್ ಜಾಸ್ತಿ ಇದೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ನ್ಯೂ ಪ್ಯಾಟರ್ನ್ and it is equally important for CET as well as NEET exams. So it's an interesting, easy and very important chapter. So it's a lengthy chapter also because there are various concepts. So we'll discuss them in part by part. So in today's class, we are discussing regarding basics of electric current, terms such as resistance, resistivity, and finding out how resistance varies by changing dimension of a body. ಈಗ ವೈರ್ನ ಡೈಮೆನ್ಷನ್ ನಾವು ಚೇಂಜ್ ಮಾಡಿದಾಗ ರೆಸಿಸ್ಟೆನ್ಸ್ ಯಾವ ರೀತಿ ವೇರಿ ಆಗುತ್ತೆ, ಸೊ ಆ ಕಾನ್ಸೆಪ್ಟ್ಸ್ನ ಇವತ್ತು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಸೊ ಟು ಸ್ಟಾರ್ಟ್ ವಿತ್, right? So first let us try to understand what is meant by current. To set the context, ನೀವು ಆಲ್ರೆಡಿ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ಸ್ ಚಾಪ್ಟರ್ ಇದಕ್ಕಿಂತ ಹಿಂದಿನ ಎರಡು ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ವಿ ಹ್ಯಾವ್ ಸ್ಟಡಿ ರಿಗಾರ್ಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜಸ್ ಅಟ್ ರೆಸ್ಟ್. When charge is at rest, what are the properties? Those things we have studied in the earlier chapter. ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ charges are considered to be moving. So we are discussing regarding motion of charges, and when charge is moving, what happens is there is electric current. Okay. So if you consider any conductor, so metallic conductor example ತಗೊಂಡ್ರೆ, so in metallic conductors there are charge carriers. There are free charge carriers which are called as free electrons. So unbalanced, I mean the charges which are freely moving, those charges we are talking about. So these charges are called as free electrons. So free electrons are the charge carriers in metallic conductors. ಈ ಫ್ರೀ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ಸೊ ದೇ ಆರ್ ಇನ್ ರ್ಯಾಂಡಮ್ ಮೋಷನ್ ಆಕ್ಚುಲಿ ಬಿಕಾಸ್ ಆಫ್ ದೇರ್ ಥರ್ಮಲ್ ಎನರ್ಜಿ. ಸೊ ಈ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ದೇ ಆರ್ ಮೂವಿಂಗ್ ರ್ಯಾಂಡಮ್ಲಿ in all possible directions, and this random motion of electrons is not causing any current. Okay, so when we say current is flowing, whenever there is a potential difference applied across the same conductor, if there is a potential difference applied, how do we apply a potential difference? Potential difference can be applied by connecting it to a battery or a cell. Okay, so by this arrangement, e free charge carriers over and above their random motion, they start drifting in a particular direction. So having connected positive potential here, so electrons gradually opposite directionally drift ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So this movement of electrons in opposite direction to that of the electric field results in electric current. Just to take an example, where we see electric current, so this device that we are using, they are actually using electric current. Okay, so natural phenomena ತಗೊಳ್ಳೋದಾದ್ರೆ lightning is an example of movement of charge. Large amount of charges are moving from one cloud to another cloud or from cloud to the ground. So this is an example of flow of charges, motion of charges. Okay, so let's see what is the formal definition of current. So current is represented by symbol I. Okay, current I is measured as rate of flow of charges. That means amount of charge flowing Q per unit time is called as electric current. So electric current by definition is I is equal to Q by T. So here Q is measured in terms of coulomb and T is measured in terms of second. So I is measured in terms of coulomb per second, and this coulomb per second is given a special name called ampere. Okay, electric current is measured in terms of ampere. Electric current is a fundamental quantity, as you know, one among the fundamental quantities electric current is. Now let us see what are the various types of current. How do we describe various types of current? Currents alli ಬೇರೆ ರೀತಿ ಇದೆಯಾ? Let's find out. So if you wanted to find what is the current flowing through a wire at a given instant of time, ಆ ಥರ current ನ ಏನು ಕರಿತೀವಿ ನಾವು? So current types, if you take, instantaneous current. as you understand, instantaneous means at a given instant of time, at a moment of time, at a given small interval of time. So what is the value of current at a small interval of time is called as instantaneous current. So by definition, instantaneous current, let me call it as I inst, and this is equal to dq by dt. Differentiation of charge with respect to time is called as instantaneous current. So if you differentiate, if charge is given as a function of time, if charge is given as function of time, the rate of change of charge or rate of flow of charge with respect to time through any section of conductor is called as instantaneous current. Let's take average current. Average current, I average, is defined as total charge flowing divided by total time taken. If the amount of charge flowing is, let's take Q total by T total, so this gives the value of average current. We'll take up examples how to find out instantaneous current and how to find out average current. Okay, so that's about types of current in terms of time. Are we measuring time, current at a given instant? Are we measuring current in a some finite time? So based on that, we have instantaneous current, we have average current. Okay, I hope these things are clear. Here discussing what is meant by current. Current is a scalar quantity. Current is the fundamental quantity. SI unit of current is ampere. We are discussing what are the types of current. Currents are of two types, instantaneous and average. Okay, so let's take how we describe current based on whether its magnitude is remaining constant or not. Okay, so based on magnitude, let me write here. Based on magnitude, current can be either steady current or variable current. Steady current and variable current. What is meant by steady current? Imagine there is a conductor. If amount of current flowing through the conductor is constant with respect to time, if it is not changing, okay, for example, in this wire, if 2 ampere current is flowing, if it's constantly 2 ampere now and after some time also, if it is constantly 2 ampere with respect to time, we call such kind of current as steady current. Graphically, a steady current can be represented like this. This be current axis and here is time axis. Current is remaining constant with respect to time, same magnitude. So graphically we can represent like this. Variable current, as you know, variable current is current where the magnitude of current through the wire is or conductor is changing with respect to time. It may be increasing, it may be decreasing, it may be periodically increasing and decreasing. Okay, so let me take an example of variable current as alternating current, as we have a chapter also, alternating current, where there is a continuous variation of magnitude of current and periodic of direction of current. So alternating current is an example of variable current. Okay, so these things are regarding basics of current. Now let us understand what is the relation between current and some microscopic properties of conductor, such as number density of electrons, electronic charge. Okay, so what are the relation between current in other parameters? We'll try to understand. Apart from this basic definition, I is equal to Q by T, and I is given by I instantaneous is equal to dq by dt. I average is equal to total charge by total time. So hope these things are clear. We'll move on to next one. Right. So as you know, the microscopic properties of conductor, such as number density of electrons, if you consider a conductor, this conductor can be characterized in terms of number of free electrons that are present per unit volume. That is called as number density. Okay, N is the symbol, N is called as number density. Okay, n is number density of free electrons. Now these free electrons are randomly moving, and when their potential difference applied, potential difference ನಾವು ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಬ್ಯಾಟ್ರಿ ಅಥವಾ ಸೆಲ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ they start moving in a particular direction. Average velocity with which they are moving is called as drift velocity. Okay, you already studied the definition of drift velocity. Let me quickly recap. Drift velocity is the average velocity with which electrons are drifting through the conductor. ಈ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಮಾತ್ರನೇ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗುತ್ತೆ ವಿತ್ ಓವರ್ ಅಂಡ್ ಅಬೋವ್ ದ ರ್ಯಾಂಡಮ್ ಮೋಷನ್ ದೇ ಸ್ಲೋಲಿ ಸ್ಟಾರ್ಟ್ ಡ್ರಿಫ್ಟಿಂಗ್. ಓಕೆ, ಆ ಡ್ರಿಫ್ಟಿಂಗ್ ಮೋಷನ್ ನ ಕರಿತೀವಿ. ದ ಸ್ಪೀಡ್ ವಿತ್ ವಿಚ್ ದೇ ಆರ್ ಡ್ರಿಫ್ಟಿಂಗ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ. Let us see what is the definition of drift velocity. Drift velocity is represented by symbol Vd, V subscript d, and Vd is equal to minus E into E tau by m. Okay, this is the equation where E, small letter E is the electronic charge, capital letter E is the electric field applied here. Okay, and tau is called as relaxation time. Relaxation time is the average time gap between two successive collisions. So between two collisions there is some time gap. Average time gap taken, okay, average time gap between two successive collisions is called as relaxation time tau, and m is the mass of free charge carrier, that is electron. Okay, so this is the expression for drift velocity. Okay, let's consider what is the expression for current in terms of drift velocity. We are actually talking about current. Let us find out what is the expression for current. So current I can be defined in terms of expression for current in terms of the microscopic properties of conductor, such as number density of electron. Number density of electron is given by small letter n, as we discussed, and E is electron. A is cross section of the conductor. Cross section of the conductor is A, which is actually perpendicular to direction of flow of charges. If charges are flowing in one particular direction, then a plane perpendicular to direction of flow of charges, that area is called as cross section area, and drift velocity is the velocity with which they are drifting, average velocity. Now this gives the equation for current in terms of drift velocity. So here if you take the ratio of current to area, this current to area ratio is called as current density. The ratio of current to area is called as current density, which will have unit of ampere per meter square. Ampere per meter square is the unit of current density. Current density is a vector quantity. The direction of current density is along the direction of electric field. Our direction of current density is along the direction of positive charges. Okay, so direction of current density is along the direction of flow of current. Okay, now ಯಾವ conventional direction current ಏನು ತಗೊಳ್ತೀವಲ್ಲ ಆ direction ನೇ current density direction ಆಗಿರುತ್ತೆ. Okay, its unit is ampere per meter square. Now equation for current density from this expression is I by A is equal to NE into VD. So current density is given by NE into VD. This is the equation for current density in terms of drift velocity. There is another important relation for current density, which is represented by symbol I. J. J is the symbol for current density. So another expression for current density is this. Current density is equal to current density J is given by sigma into E bar. J is the current density and E is called as electric field. J is called as conductivity. Okay, so this is also called as vector form of Ohm's law. Okay, this relation is also known as vector form of Ohm's law. Okay, now let me also list other formulas that we discuss in this topic. That is definition of sigma. Sigma can be defined in terms of n e square tau by m. So sigma by definition is given by sigma is current conductivity of conductor by n e square tau by m. Okay, so this is relating sigma is equal to n e square tau by m. So with these basic formulas, let us now take up questions so that we can practice how to find out value of current, how to find out charge, what are the various parameters. ಈ ಇದರ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ನ ಫ್ರೇಮ್ ಮಾಡಿದ್ರೆ if one of the quantity is unknown, how to calculate that unknown quantity. So we'll take up examples and see. Right, now let's take the next example. If there is an electron if there is an electron that is revolving electron produces electric current. Let's say this is nucleus and an electron is revolving around the nucleus, and this continuous revolution of electron is a flow of charge. Okay, that flow of charge results in current. Let us see what is the expression for current associated with revolution of electron. See, electron is revolving. It is revolving with the frequency. Let's take f. F is the frequency. How much ever time it takes to complete one round, one revolution around the nucleus, that is called as time period. Let T be the time period of revolution of electron around the nucleus, and F be the frequency of electron around the nucleus. Then current by definition, by definition it is current I is equal to Q by T. And here what charge is flowing is E, electronic charge. And what is the time it takes to complete one round, which is the time after which every time it crosses. Let's take this is the point under consideration. Illi electron cross ಆದ್ಮೇಲೆ ಮತ್ತೆ after how much time again electron is crossing here, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮತ್ತೆ ಅದು ಬರೋದಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತಲ್ಲ ಅದನ್ನ ನಾವು ಟೈಮ್ ಪೀರಿಯಡ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಕರೆಂಟ್ ಬೈ ಡೆಫಿನೇಷನ್ ಈಸ್ ಗಿವನ್ ಬೈ E by T, where E is electronic charge, T is time period. Okay, so reciprocal period 1 by T is equal to frequency of revolution, we know. So substituting this, current I is equal to E into F. Give another expression for current. Revolution of charges revolve ಆಗುತ್ತಿರೋ situations ಇದ್ದಾಗ, then what is the value of current produced because of revolution of charges? So amount of current produced is given by I equal to E into F, where E is electronic charge, F is frequency. All right. Right. So with these things, let's take up questions. So let's consider question number 1. Let there be a conductor. Okay. So let there be a conductor through which amount of current flowing I is equal to 4.8 ampere. So ನಮಗೆ data ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ? Data is that let there be a conductor in which current flowing is equal to 4.8 ampere. Okay. If 4.8 ampere current flow ಆಗ್ತಾ ಇದ್ರೆ, then we need to find out what is the number of electrons that crosses any section normal to the direction of flow of currents per second. So ಇಲ್ಲಿ ಒಂದು section ತಗೊಳ್ಳೋಣ. Let's take some arbitrary section. In this section, we need to find out how many number of electrons are crossing. Let the number of electrons crossing this section be equal to n. Okay, see ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, current flow ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ there are flow of charges also. Okay, the current is because of flow of charges. ಎಷ್ಟು charges ಈ section ಅಲ್ಲಿ flow ಆಗುತ್ತೆ, that's what the question is. So how do we find out? ನಮಗೆ current ಗೊತ್ತಿದೆ, current is equal to 4.8 ampere. How much is the time? Time in this question is given 1 second. Okay, if time given is equal to 1 second, let us find out how many electrons will be crossing this section of the conductor. Okay, anyway, as you know, ಇದು conventional direction of current ಈ direction ಇದ್ದಾಗ electrons ಈ direction ಅಲ್ಲಿ cross ಆಗುತ್ತೆ. Electrons will be crossing in a direction that is opposite to conventional direction of current. Okay, so 4.8 ampere current ಬರಬೇಕಂದ್ರೆ ಎಷ್ಟು electrons cross ಆಗಬೇಕು per second is the question. So by definition current I is equal to Q by T. Okay, so let's calculate what is the value of Q. Q is equal to I into T. So our value of Q is equal to 4.8 into T is equal to 1 second given. So our value of Q is equal to 4.8 coulomb. So total charge that is section of the conductor is equal to 4.8 coulomb. If 4.8 coulomb charges flow ಆಗ್ತಾ ಇದ್ರೆ, what is the number of electrons? So we need to find out the value of number of electrons. Number of electrons is given by quantization of charge. By definition, quantization of charge is given by Q equal to n into E, where n is an integer. N is an integer. This is quantization of charge, one of the fundamental properties of charge. Now here we need to find n. Okay, so n will be equal to Q by E. Okay, so n is equal to Q is given 4.8 coulomb, and we know what is the charge of electron. Charge of electron is 1.6 to 10 power minus 19 coulomb. Okay, so coulomb getting cancelled. You see this is 3 times 10 power 19. So how many electrons are crossing the any section of the conductor for a steady current of 4.8 ampere is this much. 3 in 10 power 19 electrons are crossing any section of the conductor per second. Every 1 second ಅಲ್ಲಿ ಇಷ್ಟು electrons cross ಆಗ್ತಿರುತ್ತೆ. All right. Okay, so if you are given the value of current, asked to find out the value of charge, current to time ಕೊಟ್ಟಿದ್ದು charge calculate ಮಾಡಬೇಕಂದ್ರೆ, then we can use this relation. Current charge is equal to I into T. Charge Q is equal to I into T. If you once you know the value of charge, if you wanted to find out how many number of charge carriers are there, so number of charge carriers or number of electrons that are crossing any section of the conductor can be determined by this relation. Q is equal to N into E and N is equal to Q by E. Okay. Let's take the next question. Right. Here let's consider expression for charge. So let there be a conductor. Let's take an equation for current. Sorry, charge. If charge Q is given to be equal to T square plus 4T plus 5. If you are given charge Q flowing across a section of a conductor is a function of time given by Q equal to T square plus 4T plus 5. If this is the question given, then we can find I instantaneous. I instantaneous at T is equal to, let's find out while instantaneous current at T is equal to 2 seconds. Also find I average current. Okay. T is equal to 0 to T is equal to 3 seconds. Alright. So if you are given the equation for charge as a function of time, we can find out the value of instantaneous current, I instantaneous. I instantaneous by definition is given by dq by dt. I instantaneous is equal to dq by dt. Okay. So it is d by dt of q. What is q is given by? It is t square plus 4t plus 5. Okay. This is the expression. Let's find out now what is the value of I instantaneous. So differentiating this, differentiation of t square is 2t, differentiation of 4t is 4, differentiation of constant is 0. So it is 2t plus 4 is the value of instantaneous current. Now let us find out what is the instantaneous current. T is into 2 seconds. So at t is equal to 2 second, what is the value of I? I is given by, substitute the value of t is equal to 2 second here. So it is 2 into 2 plus 4 will be equal to 8. So 8 ampere is the value of instantaneous current. Okay. Alright. So instantaneous value of current comes out to be equal to 8 amperes. Now let us find out what is the value of average. Okay. To find out the value of average current, what is I average is equal to? I average is equal to total charge Q total by T total. Okay. So total charge divided by total time gives the value of I average. So let's find out what is I average. See, substitute the value of, see how to find out the value of total charge. Total charge will be equal to, see charge equation in function of time. Substitute the value of T is equal to, what is the starting point? T is equal to 0. If you substitute, you see, okay, let's write like this. It is Q2 minus Q1 divided by some T2 minus T1. Okay. I average can be defined in terms of total charge divided by total time. Total charge will be equal to Q2 minus Q1 divided by T2 minus T1. So this Q2, what is the value of charge at T is equal to 3 seconds. So we need to find out the charge at 3 is equal to 3 seconds. So substitute the value of T is equal to 3 seconds here. So you will get 9 plus 12 plus 5. Okay, this is the value of charge Q2. Let me write equation one by one. This is our Q2. Let's take what is the value of Q1. Q1 is when the time t is equal to 0. Okay, if you substitute the value of t is equal to 0, you will see that Q1 comes out to be equal to 5. Okay, what is the value of total charge? Total charge is 12 plus 21 plus 5 minus 5 cancels, so it is 21 by time taken. What is the value of total time taken? From 0 to 3 seconds is 3 seconds. Okay, so if you find out, you will see that I average is equal to, here it is 9 plus 12, 21, 21 plus 5 minus 5 cancels, so it is 21 by 3. This gives 7. So the average value of current comes out to be 7 ampere in this case, and the instantaneous value of current is equal to 8 ampere at t is equal to 2 seconds. Okay, so like that, if you are given the value of equation for Q, you can find out the value of instantaneous as well as average current. So by this method. Okay, please make a note of this. So let's move on to next one. So question number 3 is this: the current flowing through a wire depends on time as I equal to 3t square plus 2t plus 5. If you are given current I is equal to 3t square plus 2t plus 5. Okay, so current expression, current is a function of time given andre steady current alla, it's a variable current. So current na time expression alli ಬರ್ದಿದ್ದಾಗ, if this is the equation for current, let's find out the charge flowing through the cross section of the wire in time t is equal to 0 to 2 seconds. Okay, so okay, so please observe this question. I is equal to 3t square plus 2t plus 5 is the equation for current as a function of time given. So ಈ ತರ equation ಅಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗುತ್ತೆ ಕರೆಂಟ್ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಫ್ರಮ್ t is equal to 0 to t is equal to 2 seconds. So ಒಂದು ಡಯಾಗ್ರಾಮ್ ತಗೊಂಡ್ರೆ, let's consider here is a conductor. ಇದರಲ್ಲಿ current I flow ಆಗ್ತಾ ಇದೆ in this direction, let's take, and this is the equation as it varies with respect to time. Let's take any arbitrary section. ಈ arbitrary section ನಲ್ಲಿ, so what is the value of charge flowing is the question. So we need to find out how much is the charge flowing in this case. See, constant current iddaga, then we use this relation I is equal to q by t, and this gives q is equal to I into t. So this equation can be used whenever there is a constant current. Steady current iddaga directly I into t will give the value of charge. But ಇದು variable case ಇದೆ, ಅಂದ್ರೆ current is not a constant current, current is a function of time. As the time increases, current value ಕೂಡ vary ಆಗ್ತಾ ಇದೆ. So ಈ ತರ case ಅಲ್ಲಿ how to find out the value of current, how to find out the value of charge, let us see. Now to find out the value of charge, let's write this equation. I by definition is equal to dq dt, right? We have discussed this. Instantaneous current is given by dq by dt. ಇದನ್ನ ನೀವು dq ಗೆ expression ಬರೆದ್ರೆ dq will be equal to I into dt ಆಗ್ಬೋದಾ? dq is equal to I into dt. Now this dq is given by, what is I? I is this 3t square plus 2t plus 5. This is the equation for I dt. Now this is the equation for dq, small amount of charge that is flowing through the conductor in this cross section in a small interval of time dt. But what we require to find, we need to find out what is the total charge that is flowing from t is equal to 0 to t equal to 2 seconds. Andre time 0 ದಿಂದ 2 second ಅಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಫ್ಲೋ ಆಗುತ್ತೆ ಈ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ, that's what we need to find out. So let's find out the value of charge q. See, integration of dq is equal to q. Okay, so q is equal to integration of dq, this is integration of this term 3t square plus 2t plus 5 dt. Okay, let's find out what is the value of q. So q is into different integration of 3t square. Integration of 3t square is 3 t cube by 3 plus integration of 2t is equal to 2 t square by 2t square by 2, and integration of 5t will be equal to, integration of 5 is equal to 5t. Okay, substitute the limits. 0 to 2 seconds. Okay, here limits of integration are from 0 to 2 seconds. So time ಇಲ್ಲಿಂದ vary ಆಗ್ತಾ ಇದೆ. Time is varying from 0 to 2 seconds. Okay, now if you simplify this 3 and 2 here, so we have an equation for q given by this tq plus t square plus 5t. Limits of integration are from 0 to 2. Substitute the upper limit minus lower limit. So lower limit ನೀವು substitute ಮಾಡಿದಾಗ ಎಲ್ಲ term ಅಲ್ಲೂ t ಇದೆ, so it will become 0. So charge q will be equal to, it is 8 plus 4 plus 5 into 2, 10. Okay, so q comes out to be equal to 22. 22 coulomb will be the value of charge. Okay, how much charge is flowing across any section of the conductor? For this expression for I, equation ಈ ತರ ಕೊಟ್ಟಾಗ current equation, what is the charge flowing through the any section of the conductor will become this. Okay, so I think this integration is understood. Integration of 3t square is equal to 3 t cube by 3. Integration of 2t will be equal to 2t square by 2. So 2 ಮತ್ತೆ 3 cancel ಆಗುತ್ತೆ. Integration of 5 dt will be equal to 5t. So please make a note of the answer. Right, let's move on to next one. Let's take this question. If an electron revolves in a path of a circle of radius 0.5 in 10 power minus 10. So let's take this is question 5. So electron is revolving in a circular path of radius r given by r is equal to 0.5 10 meters. Okay, charge of electron, as you know, it is 1.6 into 10 power minus coulomb, and the frequency with which electron is revolving here is given by 5 in 10 power 15 cycles per second. F is given 5 into 10 power 15 cycles per second. Okay, now what is the value of current? Find current along the orbit. So electron is revolving. This is the radius of the circular path. This is the electronic charge, frequency of revolution, cycles per second. What is the value of current associated? See, this revolution of electron. Electron is, if you take any particular part, electron is crossing this region every time. Okay, how many cycles it is doing in 1 second? In 1 second, it is completing 5 into 10 power 15 cycles. 5 into 10 power 15 times 1 second ಅಲ್ಲಿ electron revolve ಆಗ್ತಾ ಇದೆ. So how much current it can produce? So current produced is given by, as we already discussed, I is equal to q by t. ಇಲ್ಲಿ q ಏನಿದೆ, it's electronic charge, charge of electron, and how much time it takes to come across this point once again is called as time period. Reciprocal of time period is called as frequency. So we have E into F. Okay, so current I is equal to electronic charge into frequency. So I is equal to electronic charge is 1.6 into 10 power minus 19, and frequency is given 5 into 10 power 15. So I is equal to 16 5 is 8 into 10 power minus 4, or it is 0.8 10 power minus 3 ಅಂತ ಬರಿಬಹುದು, right? So 0.8 10 power minus 3 milli. So it is 0.8 milliampere is the value of current that is produced by revolution of electron. Electron revolve ಆಗ್ತಾ ಇದ್ದಾಗ ಎಷ್ಟು current ನ produce ಮಾಡುತ್ತೆ? That is given by this expression for this values. All right, let's take the next question. Right, question 6 is this: a conducting wire having 10 power 29 free electrons per meter cube. So let me write the data of the question. Here is a conductor. Okay, the conductor only, there are free electrons, number of free electrons per unit volume, which is represented by small letter n. Small letter n represents number of electrons present per unit volume. So number of electrons present per unit volume is given 10 power 29 per meter cube. Andre 1 meter cube volume alli 10 power 29 free electrons ಇದೆ and carries a current of 20 ampere. Amount of current flowing through the wire is given 20 ampere. The cross section area of the wire is having a cross section area of 1 millimeter square. So ಇಷ್ಟು cross section area ಇದೆ. The area of cross section of this wire is 1 millimeter square. What is the drift velocity? Find drift velocity of electrons. Of course, free electrons. So what is the value of drift velocity of free electrons? Okay, right. Namge we know the equation for current. So by definition, you know, current I is equal to NEAVD. Current I is equal to NEAVD. So we need to find out the value of VD here. ಇಲ್ಲಿ I represent current, N is number density of electrons, E is electronic charge, A is cross section, VD is drift velocity. So equation for drift velocity is given by I by NE into A. E formula use ಮಾಡಬಹುದು, right? We need to find out the value of drift velocity. So we can use this relation. VD equal to by NE into A. Substitute ಮಾಡಿ values na. I, value of I is given by 20. Okay. Number density of electrons 10 power 29. Electronic charge 1.6 into 10 power minus 19. Area is given 1 millimeter square. So 1 millimeter square na ನಾವು meter square ಗೆ convert ಮಾಡಿದ್ರೆ it is 10 power minus 6 meter square. 1 millimeter square is 10 power minus 6 meter square, substituting here. So we have 20 by 1.6 into, see 10 power 29 into 10 power minus 25, so will become 10 power 4, right? 29 minus 25, okay, 29 minus 25 is 10 power 4. So this can be further written as, see 1 by 1.6 is written as 0.625. 1 divided by 1.6 is equal to 0.625 into 20 into 10 power minus 4. Okay, see here, this is written as 6.25 into 2. Six point two five 10 power 6.25 into 2 into 10 power minus 3. So multiplying, you will have, this is the answer. This is 12.5 into 10 power minus 3 ampere. Okay, I'm sorry, this is 10 power minus 4 here. Right, simplifying this, you see, this is 6.25 into 10 power minus 4 into 2. So the answer is 12.5 into 10 power minus 4. The final answer can be written as 1.25 milliamperes. Okay, so what is the value of, find the value of, I'm sorry, we are finding the value of drift velocity. So our unit is 1.25 10 power minus 3 meter per second is the value of drift velocity. So here in this question, you have been given the data, number density of electrons, electric current, this is the area. What we need to find out is the value of drift velocity. So what formula we are using is this, I equal to NEA VD, and VD is equal to I by NE into A. Okay, substituting all the values, you will arrive at the value of drift velocity of free electrons. All right, so let's take the next one. So you have been given drift velocity of free electrons of a conductor is V when current is I. consider there is a conductor and current flowing through the conductor is I, and corresponding drift velocity is Vd is equal to V. Okay. So I is the value of current, V is the value of drift velocity. If both radius and current are doubled, then drift velocity will be. So in this case, if the radius, let's take the radius here is R1, okay. If radius R2 is equal to 2 times R1, if radius is doubled, and we also increasing the value of current. If current I2 is made into 2 times of I, current is doubled, radius is doubled, what happens to value of V2? What is the value of drift velocity is the question. So here we need to put an expression. We will write an equation for drift velocity in terms of current and radius. Okay, you know, we have I equal to NEAVD. Our equation for VD is given by I by NE into A. Okay, so this is written as I by NE into A is equal to pi R square. Okay, for circular area, if you consider this as a cylindrical wire, and this area of cross section will become a circular area, and area is given by pi R square. Now what is the value of this? See here, current is a variable, N are constant, pi is a constant, so we can write Vd is directly proportional to I by R square. Vd is proportional to I by R square. Now if you take the ratio of two drift velocities like V1 by V2, what is the ratio of V1 by V2? So by this expression we can write it is I1 by I2 into inverse ratio of radius, that is R2 by R1 whole square. Okay. So V1 by V2, this is equal to, see, current is doubled, that means here it is I and 2I multiplied by radius is doubled, that means it is 2R by R whole square. R let's cancel, I let's cancel. So we have V1 by V2 is equal to 1 by 2 into 2 square is 4. So if you simplify, we obtain V1 by V2 is equal to 2. That means what is the value of V2? V2 comes out to be equal to V1 by 2. Or in the question it is given as V. So V by 2 is our answer. V1 is equal to V. Okay. So in such case, wherever we have been given how drift velocity changes with respect to current and radius, if current is doubled, radius also is doubled. So we see that drift velocity will be equal to V by 2. Okay, so that's all about microscopic properties of conductor. Let us now move on to resistance and Ohm's law. So one of the important topic of current electricity is resistance, I mean Ohm's law, which defines what is resistance and which gives the relation between current and voltage. So by definition, Ohm's law is this: consider there is a conductor. If it is carrying some current I, and that is only possible because of some potential difference applied here. Okay. So what Ohm's law relates is this: the amount of current flowing is directly proportional to potential difference that is applied. ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತಲ್ಲ, ಫ್ಲೋ ಆಗೋದು ಈ ವೋಲ್ಟೇಜ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಟೆಂಪರೇಚರ್. ಆಫ್ ಕೋರ್ಸ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಕಂಡಕ್ಟರ್ ಹ್ಯಾಸ್ ಟು ರಿಮೈನ್ ಕಾನ್ಸ್ಟೆಂಟ್, T is constant. So when temperature is kept constant, current is directly proportional to voltage, or we can write V is equal to I into R. Here R is the proportionality constant, where R is called as resistance. R is called as resistance of the conductor. Okay. So resistance of a conductor is characteristic property of this material. Okay, which depends on dimension, which depends on temperature, right? It depends on nature of material. Let's see what are the parameters on which resistance depend. Before that, let us define R. R is equal to V by I. So what is the resistance of a conductor is? Resistance of a conductor is the value of potential difference that is required for unit current. Amount of current required to be flowing through the conductor. 1 ampere current na flow ಮಾಡೋದಕ್ಕೆ ಎಷ್ಟು potential difference ನಾವು apply ಮಾಡಬೇಕಲ್ಲ, that potential difference is numerically equal to resistance of the conductor. ನಾವು different material ನ ತಗೊಂಡಾಗ different voltage ಬೇಕಾಗುತ್ತೆ to have 1 ampere current. So that results in different value of resistance. So resistance is different for different materials. depending upon the nature of material, depending upon the dimension. So these are the parameters on which resistance depend. Of course, resistance depends first one on nature of material. Resistance depends on length. Resistance depends on area of cross section. Resistance depends on temperature. So these are the parameters on which resistance depend. So different materials will have different value of resistances. Conductors are having less resistance. Okay, insulators will have higher value of resistance. So if you consider length, resistance of a conductor is directly proportional to length of the conductor based on the dimension. If you increase the length, resistance also will increase. And resistance is inversely proportional to area of cross section. Resistance is inversely proportional to area of cross section and temperature. So for metallic conductors, with the increase in temperature, resistance also will increase. So we can consider R to be directly proportional to T. If you heat the wire, its resistance also will increase. Okay. Now based on this dependency on dimension, we can write an equation for resistance like this. Resistance R is equal to rho L by A. R is equal to rho L by A, where L is length of the conductor, A is area of cross section, where rho is called as resistivity. Rho is called as resistivity. It is also called as specific resistance. That means resistivity is the resistance offered by a conductor of unit dimension. That means 1 meter length, 1 meter square area of cross section. What resistance is offered by a material is called as its resistivity. Okay. So resistivity can be written like this: rho is equal to RA by L. Okay. Now this is about what is meant by resistance. Resistance will have a unit of volt per ampere, and volt per ampere is given a special name called ohm. Omega is the symbol. Okay. So ohm is the SI unit of resistance. So let's consider now how to find out the value of change in resistance whenever there is a change in dimension of the conductor. If conductor dimension is changed, how resistance is changing, let's find out. Okay. This part is important for competitive exams. Generally, there will be questions finding out what is the new resistance with the change in dimension. Okay. If R is the R1 be the initial resistance of a given wire. Let's take this is the dimension of the wire. Okay, let's take L1 is the length and its area of cross section be called as A1. A1 is the area of cross section. Now, if you change the dimension of the same, so changing the dimension method is stretching. Okay, we can stretch the wire. Wire can be elongated. Okay, if a wire is stretched, what happens? Generally, wire na ನಾವು elongate ಮಾಡಿದಾಗ area of cross section ಕಡಿಮೆ ಆಗುತ್ತೆ, length ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Okay, if length is becoming double, then area of cross section will become half. Length double ಆದರೆ area of cross section half ಆಗುತ್ತೆ. So that kind of action is called as stretching. So wire na ನಾವು fold ಮಾಡಬಹುದು. You can fold the wires where length will become half. I mean length will reduce. There will be increase in thickness. Area of cross section ಜಾಸ್ತಿ ಆಗುತ್ತೆ, length ಕಡಿಮೆ ಆಗುತ್ತೆ by folding a wire. Okay, if you there will be decrease in length and there will be increase in area of cross section. Let's take this example of stretching. So this wire, if it is stretched to increase its length to 2L, let me consider the new length as L2 and new area of cross section as A2. A2 is the new area of cross section. Now what is the new resistance? New resistance be called as R2. See, it is same wire, so its resistivity here and resistivity here remains a constant. So remember this, resistivity is not a function of dimension. Resistivity of a conductor is independent of dimension. ಈಗ copper wire ಇದೆ, whether it is a thin wire or a thick wire, the resistivity of copper wire is constant. Okay, resistivity is not changing with respect to dimension. Okay, so ಎರಡು ಮೆಟೀರಿಯಲ್ ಅಲ್ಲಿ resistivity same ಇರೋದ್ರಿಂದ we can write rho as the common resistance, I mean resistivity. Let's take resistance here is R1. Let me write an equation for R1. What is R1? R1 is given by rho L1 by A1. Okay, what is R2 is equal to? It is rho L2 by A2. Okay, now when wire is stretched, what will remain constant is volume. So volume of the wire will not change. volume remains a constant. So what is volume of a cylindrical wire? Cylindrical wire na volume na ನಾವು ಯಾವ ರೀತಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬಹುದು? It can be expressed in terms of length into area of cross section. So L1 A1 is equal to L2 A2. If volume is remaining constant, ಈ volume ನ ಏನಂತ represent ಮಾಡಬಹುದು? It is length into area of cross section. That is the volume of this wire. Okay. And here if the wire is increased to a new length L2, then what is the volume here? Volume is given by L2 into A2. This gives the value of new volume, right? But volume remains constant. Okay, initial and final volumes are same. So as a result, we can write L1 by L2 is equal to E2 by E1. Okay, right? So we can use this relation. Now to find out the value of resistance change in terms of length alone, then we can write like this. Okay, R is equal to rho L by A. See, R is equal to rho L by A. Let us multiply by L and divide by L. So if you multiply and divide by L, you will see that R is equal to rho L square by A into L. Okay, you see A into L represents volume. A into L represents volume, whether by the action of stretching or by folding. By action of stretching and action of folding, this volume will not change. Volume constant is there. Okay, so volume constant ಇರೋದ್ರಿಂದ R can be observed to be directly proportional to L square. ಇಲ್ಲಿ rho constant ಇದೆ, resistivity, volume constant ಇದೆ. So R is proportional to L square. Okay. So ಈ relation ಅಲ್ಲಿ R1 by R2 will be equal to L1 by L2 whole square ಅಂತ ಬರಿಬಹುದು. Right. So this is the important result. For example, if you take L2 is equal to 2L1, length double ಆಗಿದ್ದಾಗ resistance ಏನಾಗುತ್ತೆ ನೋಡೋಣ. R1 by R2 will be equal to, it is L1 by 2L1 whole square. Okay, so will become 1 by 4. Okay, cross multiply ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? You will see that R2 comes out to be equal to 4 times R1. ಅಂದ್ರೆ length ನ ನಾವು double stretch ಮಾಡಿದ್ರೆ then resistance equal to 4 times the initial value. Okay, if you take, if L2 is equal to 3L1, then our R2 will be equal to 9 times R1. Okay, resistance 9 times ಜಾಸ್ತಿ ಆಗುತ್ತೆ whenever length is increased to 3 times. So this is the basic concept of finding the value of new resistance whenever there is a stretching of wire. So we have discussed in today's class what is meant by current, how to calculate current in case of no constant case and case of variable case. We also have discussed regarding Ohm's law and resistance. We have discussed how resistance changes with change in length. Okay, so more numericals on this we will discuss in the next class. In the next class, we will also discuss regarding combination of resistances. Okay, series combination, parallel combination, and Wheatstone bridge network. These concepts we will discuss in the next class. Thank you so much. Thank you, one and all.